Um,
Good, Good morning, dear parents. Welcome to our online STEM fair. Today, we'll be presenting all our wonderful experiments, models, and presentations. So we're going to be doing this row-wise, starting with roll number 1, Api. But unfortunately, he's not here. So we'll be continuing with roll number 2, Tuba.
So, good morning, dear parents. Let's take a look at my presentation. So, good morning, dear parents. Welcome to my presentation on the model I made on angles. So, the resources I was needed to make this model was some boxes, some sticks, some wood foam, and some beads for decorating. So the functions are like this model demonstrates a lot of angles. Like it shows the basic angles, pairs of alternate angles, corresponding angles, and etc. So basic angles of are in this model are the first is complete angle, which is like fully 360 degrees. Then there is acute angle, which is less than 90 degrees, less than 90 degrees. Then there is obtuse angle, which is more than 90 degrees but less than 180 degrees. But then is right angle, which is 90 degrees, then a straight angle, which is 180 degrees straight. The other angles in this model are adjacent angle, who has a common arm and a vertex. So this angle is like side by side, adjacent. And then we have linear pair, which a linear pair is formed when two adjacent angles are sum of two adjacent angles make 180 degrees. So it like adjacent angle, this also has a common vertex and a common arm. Then there is alternate angle. Alternate angle is when two lines cut a line when two parallel lines are cut by the transversal. You may be thinking, what is a transversal? Transversal is the line which cuts two parallel lines. Then there is interior angle, which are the angles formed inside the shape, and exterior angle, which are formed outside the shape. So what I have learned. So I have learned a lot of angles, like a lot of angles in my class, the different types of angles, pairs of angles, alternate angles, corresponding angles, the transversal, a lot of things in my class. So that's why I thought to show my understanding on different types of angles in through a model. The real life use. So it can be used in like schools. Students can have fun learning. They can like look at a friendly model and see the angles. So all the angles are demonstrated in this model, so they can have fun learning. And also, we all know that engineers and architects use angles because they need it to like build roads, buildings, and etc. So these they also need angles, and also athletes need angles because it enhances their performance better. Also artists, because they can draw things in different angles, etc. So hope you liked my presentation. Um, thank you.
আমাদের তো সবার আছে।
Okay, I think we can move on to the next presentation. So I would request Abrar to please start.
তোমার চেহারা পুরোটা আসলে কিন্তু তুমি নিজে দেখতেছো না? আচ্ছা,
I think Abra disconnected. Abid is here.
Okay, Abid, would you like to start?
Number 1.
Abid, would you like to start?
Okay.
Okay, start your presentation, Abid.
Good morning, dear friends and parents. My project was tiny ring shelter. So, my project, when I was making it, the resources I used were cardboard, scissors, tape, and paint. And the concepts I have used here are math concepts. The concepts are shapes and measurement. As you can see, there are squares, rectangles are used here. And I have also used measurement to measure out the pieces, because when I was cutting the cardboard, I needed certain measurements. Now, you may ask, what is the purpose of my project? The purpose of my project is, well, imagine if it was in real life. In real life, the purpose would be, if there was heavy rain and there was nowhere else to go, you could take shelter here. And this way, it would be a safe place, because if there's heavy rain, it will be waterproof and it will be like it will be a strong structure. Thank you.
Abid has presented an awesome model. Now we're going to be moving on with Alvin.
So, good morning, dear friends, parents, and teachers. My name is Alvin, and for this year in STEM, I chose engineering, and I made an egg drop cage. When you put an egg inside that cage, you can throw the cage, drop the cage, whatever, and the egg would not crack or break. It's an extremely simple cage design that is very effective. All you need are about 15 straws, 2 to 3 inch wide tape, some hot glue, and 6 long skipper-like things. So now, how to build it? It's actually quite simple and easy to make. First of all, just cut 6 roughly 3-inch straws and then put them into a pyramid. Make them into a pyramid. A tree for the base, and then 3 connecting in the middle from each meeting point of the base things. I actually held the straws in and made the pyramid with hot glue, even though you can also do that with tape, but I myself found it much harder to do it with tape, and I just found it easier with hot glue. You can do with whichever one you want. Both of them, after a while, they will just come off and the thing will break apart, but they both work good enough. And then take two normal size straws, tape them together to make a longer like mega straw. Make 6 of those very, very long straws, and then put each of those long straws on each side of the pyramid that we just made. So now stiffness is actually very important because those straws that are on the pyramid are what are going to be protecting the egg. So now my straws went that stiff, so I took long skewer like things and then just put them through the mega straws and held them with hot glue on each ends to make them a bit stiffer. So now here's a clip from another time when I dropped the cage from quite high. The egg was inside the cage and the egg did survive. So now that's a perfect example. The straws take the impact and the egg has to do nothing. So now how it works. The way it works is quite simple. First of all, when the cage impacts surface, either one straw or multiple straws get all the force. Not all straws get the force. Not all the straws are will be touching the surface. Uh, so now what happens is all that force that gets, it goes to the stiffest path of the straw all the way to the top of the straw, and then it just goes away. The impact doesn't break the egg or crack it or anything because the all the force is just going beside the egg, not directly at the egg. If you had the straws directly on the egg, like the end of the straw touching the egg would break immediately because that would be too much pressure for the egg to take. So now another thing is since I used hot glue to hold in the skewer things to make the straw stiffer, hot glue gets a bit rubbery after it dries. So now one of the most important things when you want anything to survive on any fall or anything is to spreading that impact over a longer period of time. So now what the hot glue rubbery bit does is compress, and that spreads the amount of time. That's the same thing that happens with airbags, the same usage, spreading the force over a longer period of time. So now usage in real life. There can be many usages of this method in the real world. So now let's say NASA, SpaceX, or any company or person with a lot of money wants to send a rover to Mars that is smaller and lighter than any other rover that has already been sent to Mars. They can use this method by just enlarging the cage, because obviously you have to make it bigger, and then making the part stronger, switching the straws up with solid metal, and also closing up the holes because there will obviously be holes, closing it up so that the rover doesn't just fall out. And there may be some inflating balls on the pyramid if the rods break, and some rubber on the ends of the rods because, well, my one also had the rubbery hot glue bit. It will theoretically work. It might work if you make, instead of a pyramid, you make it a cube. I'm not sure. I haven't tested it. It should probably work. Not sure though. Another reason it will actually work on Mars is Mars has a third of the gravity of Earth. So when you have a lower gravity, you weigh less, which is quite good because if you do all the things I just said above, it will be quite heavy, and it needs to be light to, because the more weight, the more force. So if it's lighter, less force, which is good because that means our metal rods will not break. Okay, so now my learning. What have I learned from this project? The thing I learned is nothing has to be complicated. Simple is good. Simple things can do the job completely fine. Thank you for watching.
Wow, Alvin's presentation was awesome. Now I'll be presenting my presentation. So today I'm going to be explaining about the particles theory of different states of matter. And through my experiment, that it will explain the concept of density for matter. We all know that matter exists in 3 states: solid, liquid, and gas. Each of these can be differentiated by the density of the particles that consist in them. we ever wonder why oil floats on water? Do we know why a marble sinks in water? It is because of density. Density is a measure of a mass of an object per unit volume. So before I show you my experiment, I want to explain a little bit about the particles theory of different states of matter. The first state of matter is solid. The atoms and molecules in a solid are packed together much more tightly than in a liquid or a gas. The atoms and molecules in a solid have fixed positions. Unlike liquids and gases, they move around. Solids are usually much more dense than liquids and gases, but not always. Secondly comes liquid. Every liquid has a density. In liquids, the density determines if the substance will float or sink in the particular liquid. Each of the liquids have different mass of molecules or different numbers of parts squashed into the same volume of liquid, which makes them have different densities and therefore one sits on top of the other. The more dense the liquid, the heavier it makes it. Lastly comes gas. The density of gases is strongly affected by the pressure and temperature of the particles. The particles in a gas are a long way apart. They move around very quickly, and gases are easy to squash because there is a lot of space between one and the other particle. So now I'm going to be demonstrating my experiment. So the things I needed for this experiment were floor cleaner, water, oil, different colors of food coloring, a syringe or a dropper, a spoon, a marble, one wood stick, 4 cups, and a long cup. So the first thing I did for this experiment were take my 4 cups and make different sugar solutions. I gave different amounts of sugar in each of the cups, and I gave food coloring to represent their solutions. Then I have poured the highest amount of density, which was the pink one, and as you can see, it went right in the bottom. Like this, I have done my full experiment, and as you can see, they're all separated in layers. At last, I have given the oil, as you can see. So now what I'm going to be doing is taking this wood piece, and I'm going to be throwing it. As you can see, the wood piece is right on top of the oil. Do you know why that happened? It was because the solid wood piece is less dense than the oil, so it went on top of it. But now, if I take this marble and throw it, you can see that it went right in the bottom. That happened because the marble is more dense than any of the liquids which are here. And you can also see that the oil and the floor cleaner and the water, they didn't mix. That is because the oil is less dense than the water or the floor cleaner. And another reason why is because all 3 of these liquids are immiscible liquids, which means they don't mix, even if we shake them. So now I'm going to be taking the straw and I'm going to be blowing. You saw that there were many bubbles over here. Do you know why that happened? That was because of gas. Gas is lighter than any of the liquids, so it quickly went in, then got out. So that was all for my experiment. So dear parents, you have seen all of my group's presentations. So now can you, do you have any questions or any comments for us?
Arisha, Abrar is here. I think Abrar can continue
Yes,
his
miss.
one.
Okay, so Abra, you can continue your presentation.
Wait 1 second, I'm turning on the screen. This is my presentation. I made a game which is a snake game, and I used 2 coding languages, which is Java and HTML. So let's start by the coding stuff. So this is the coding for the snake game. So this is the center tag. This is the center tag. What it does is basically the whole coding stays in the middle. So if I remove the center tag, the whole coding thing will be on the left side of the page. So this is the next one is the header tag. Header tag is basically
the header. So you could, like, as you can see, I wrote, "Hi, welcome to my presentation on the snake game made by Java and HTML." So that's the header, and this is the paragraph tag, which is where you can write the paragraph by using that tag. And now come to let's and this is the canvas. The canvas is basically the place where the game runs, like this thing over here, the black thing. And this is the, like, how fast the game will run. For example, if I give it about 200 by 15, as you can see, it will be really fast, because like that's like really fast because I made it like way faster. So that's the code for making it fast and slow. And now this is the tail code. This is the code for the snake, where if the snake hits the yellow part, the the yellow part, like, it's gonna be regenerated in a random spot, and the red thing will be +1. So the red will like be added one more pixel. Now let's come to the CSS part. The CSS is basically the color and the properties of the things. So for example, this is the canvas. So basically the canvas is basically 400 by 400, the width and height, and this is the CSS. The CSS color is black. So if I want, I can change it to any color. I can change it to yellow, like this. As you can see, the whole thing will be yellow. So black will be the best color for this. And then this is the snake code, and this is, as you can see, it's linked. So this part and this part, where if the snake eats the yellow part, it will be added 1. So trail length I1 plus 1. So this is the tail, like the starting point. So I can make it 4 if I want. So the starting point will be 4, like, as you can see, the 4 pixels are there in the snake. And then this is the keyboard stuff, where, like, if you press the up key, it will go there, and if you press the down key, it will go there. And this is the yellow part, which is the food. So basically, I already told it that this part and this part are linked. So if the red snake eats the yellow part, it will be like added 1+. So these are the function. As you can see, this is the part where if the snake touches its own part, then it will be breaking down, and it will return to its original form, which is which is 1. So uh, that's for my presentation on the snake game. Thank you for seeing. And now I'm gonna tell you how the snake game works basically. So this is how it works. You use arrow keys to play it. As you can see, I'm gonna show like how it works. So as you can see, I have 4 particles now. I mean pixels. So if I touch my own side, as you can see, I have already broken down to 1. So that's how the snake game works. Thank you.
Wow, Abrar, your game was very cool. So, dear parents, now you have seen all my group's presentations. So, do you have any questions or comments for us?
I don't know.
Well, hi everyone. I think you can't see me. Hello everyone. So thank you very much. I mean, absolutely enjoyable time and interesting projects. I see, I was wondering how projects are doable during this lockdown period, but you really have done tremendously well. Very interesting concepts. You have brought in mathematics, physics, chemistry, IT. What a great combination. So thank you very much. And I have put up my comments also on the chat box. Bye.
Um, so is every parent gone?
No, parents are still here. If you have question, you can ask, Zain.
Yeah, I wasn't sure if I could ask the question when the parents were here, but isn't there 4 stages of matter and one of them plasma?
Yeah, but I only talked about 3 today. I didn't
Oh,
have
because
access.
plasma
Yeah.
cannot, like, you cannot do it in your house. Okay.
Exactly.
Where are you gonna find plasma anyway?
You can just make it from fuel.
It
But
will be much safer to not.
no, I probably will burn my house down or something.
Yeah, it's probably safe to not.
Is there any new learning from the other experiment that you saw right now?
The only
Can you
learning
share anything?
I got was from like the density one because I didn't know how it worked, and the other ones include Alvin's one and Abrar's one. I didn't learn much from Abrar's one, but I at least learned that coding is not hard. That hard.
It's not that hard, I know.
It's not that hard.
I think you are already familiar with the HTML coding because you have some work in your ICT class. So yes, that was a brilliant work done by Abrar and a wonderful presentation by all of you. As you have heard the remarks from parents, we would also like to extend our thanks for all your hard work and extra effort that you have put in to create these projects. And yes, it was a wonderful presentation. Thank you. And we would like to thank all the parents also for taking the time out and coming and giving us your valuable feedback. Thank you so much for that.
Thank you, teacher.
And now I'm just opening. Thank you. Now I'm opening the floor for every one of you to just think and reflect if you would like to ask any other questions about any of the projects that has been shown. We still have about a few more minutes of this session. So you can ask questions to your friends if you have any concerns.
I'll just ask
Yes,
a
go for it,
question.
Zain.
One has a question.
I'll ask a question to, I think it was Alvin. You showed experiment on the egg and the straws. So what is the relationship, Alvin, between the force and the impact? If you could explain again.
Which bit? Like how it works, the cage?
Yes, you spoke a lot about force and what impact it created.
Okay.
In
So
your
what basically happens is when the cage like impacts surface, what happens is it impacts the surface. What happens is all the force goes through the stiffest path of the straw to the top and since the straws aren't pointed directly at the egg, the force just passes by the egg and the egg doesn't break or crack.
okay.
Yes, Zain, you can ask.
Like about Alvin, like I understand that the sticks work as a shield and all, but how does the egg stay in? How?
It's a friction. You like push it in straws, the pyramid straws. I didn't like stiff them up with the skewer thing, so you can just push it in the straws. They bend a little bit because the egg is just a tiny bit stronger than the straws, and then it just stays in with friction. Nothing else. That's why for the egg you need it to be a pyramid. You can't make it a square, or the egg will just rattle around in there.
That was the thing I was wondering.
Okay.
Because I thought that if you do that experiment and make it fall, then the egg will just drop out and break.
No. Well, it will drop out and break if the thing just like opens up.
Yeah.
If the thing breaks, like the cage breaks, or else it'll stay fine. That's why the straws for the pyramid need to be roughly 3 inches, because then most eggs won't fall through. Most eggs will sleep, unless your egg is.
Thank you, Alvin, for a wonderful explanation. Now, I would like to know, like, you have done a tremendous job, but I'm pretty sure it did not come out successful in the first go. Did any of you face any challenges while you were trying to prepare your project during the first group who presented? Those who have already presented?
Oh.
Yes, Alvin.
What happened was like on the first time I threw it like 4 times and all the tape came off. I did the entire thing again, like everything I had to do again. Through it, like it survived like a day or two, and then everything came off again. Then I had to do the entire project completely again, and that time I did with hot glue instead of tape. It wasn't easy, and like sometimes it just like I drop it, the pyramid just opens up, the egg just falls out and cracks and dies, basically. Like most of the times it did survive, except the times where it failed. Like, because I did say that the hot glue and the tape, both of them will come off eventually after a couple of drops, because this is the kind of stuff that isn't supposed to like help 1,000 eggs survive, like each of them dropping. It's only like for now, once or twice, it's gonna help it survive with the materials I used, at least.
Wow, that shows a great deal of your patience and your commitment as well. Wonderful. Now, my next question will be, which of the IB learner profile or PYP skills do you think you have demonstrated or developed during this project demonstration or preparation? Any one of you can answer that.
I would say knowledgeable, because most of the stuff I just said in my PPT and my thing, I literally didn't know any of it before. I searched it up, engineering projects stuff. I found it, and then after that I researched about it, and then I at least got to know what it is, how it works. I knew none of this stuff before. Why this stuff even works in the first place. Now I at least know.
I think you are an inquirer
That's very
also.
true, Arvind. Absolutely. And it is not just for you, it is a good learning for many of us here, because a lot of these concepts you have probably developed before or you are learning new. Many of your friends were probably not familiar with all of these concepts before, but now it's a new learning for many of us. So yes, it is definitely a great chance for us to be more knowledgeable. And as Miss said, yes, you have been a wonderful inquirer as well. So yes, thank you so much for your hard work and all the effort. Any other remarks from anyone? Or any questions? Yes, Adiba, do you want to say something?
I think I have also become like knowledgeable and inquirers, but I like because I could like show my understanding on angles in like a model, and I figured out like where these all the angles could be. So that's how I became like.
That's really wonderful, Adiba. Yes, the angles that you have demonstrated, it is a very recent topic that we have learned in math, and you have had your learning in real life. So that is actually a wonderful way of showing your knowledge and your skills too. So that's wonderful. Anybody else? Yes, Zain, any questions?
I would also like to talk.
Yeah,
sure, Aisha. Okay. Just after Zain, I'm coming to Aisha. Yes, Zain.
Through my experiment, I got to learn many things. I got to learn about the particles theory of different states of matter. I learned why oil floats in water, and why our different densities of liquids sits in layers. And I hope you guys also learned a lot about it too. So over here, I demonstrated the profile inquirer actually. I had to inquire on why this is happening and the different particles theory, etc. And I use my research skills to find those answers. And after doing that, after I presented, I gained a lot of knowledge, not only from mine, but also from others' presentations too.
All of you are a big risk taker also. Think about the platform that we are using for the STEM week. So it's a very new experience for all of us. It's a great job that you have done.
Challenges are
challenges are
yes,
everywhere.
Very true. The challenges are more than the physical environment. So you have taken a great risk and you are absolutely successful. We are so proud of your presentations. Yes, coming to Zain Mahmood Khan, please share your opinion.
Yeah, like I don't want to screw someone over, but like about Adiba Duba's presentation. Like at the first, when he showed the main angles, he did actually find the angles herself. But when she showed the other ones, like the pair of angles, then he just marked a 90-degree angle and draw the line between it, adjacent angle, and stuff like that. So how is it finding the angles? It's just drawing them, right?
The
Adiba?
basic yes, the basic angles I could like find out. So you cannot find like what do you say? You cannot find a adjacent angle in like a square, like a square shape. So I found it easy to draw because it is only showing or demonstrating the angles, and it's like finding the angles. I found the basic angles. Then I found which are the other angles, which I found it by like drawing them.
Yes, that's wonderful. Yes, what she means to say, Zain, is that it is not only about applying the angles in the model, it is also about finding the angles from the shape that she has used. That is where she has applied her understanding of the angles and the pair of angles. So what you have observed about the drawing of the lines is actually her identification of the angles in that shape. So that's what she was trying to prove there.
And
Does
Aisha, I
that
think
answer your question?
and her concept was very clear,
Yes.
Tuba, on all types.
yes.
True, true.
Thanks.
Arisha,
Thank you so much, everyone. We are
only 1 minute
yes,
left. I think
Arisha,
she
you want to
can
add something?
conclude this
Yes.
session.
Yes, Arisha, you can conclude the session and then we will go for
Okay,
it.
so now we're going to be taking a short break from 9:40 till 10:10. So I hope to see you all parents that coming back at 10:10 for the next slot to present.
Okay, thank you. Bye, everyone.
Okay. Thank you, everyone. Enjoy the break. We will see you back at 10:10.
Okay.
Thank you.
Goodbye.
Bye.
You know, my brother didn't rip my
Bye,
cage
everyone.
like today. He ripped it 2 days ago. Like I made, like the first time I made the video. Right after that, I'm like doing something else on the computer, and then my sister just comes in holding the individual straws. I don't understand what he does. Like, how much energy